Hello, I have coded something new, and it calculates the average percentage extension or retracement from the previous high or low, and compares it with the days which have passed since the last pivot. It can be useful to evaluate if the percentage difference is in line with the time which has passed since the last pivot. So in case of a previous low, the gain from the from the low would be on average equivalent to this trend line, yeah. And if it's above, then you could expect that the probability that this is a valid high is higher compared to when it would be lower. And on the other hand, if you have a previous high and you have a retracement and you compare it with the time which has passed since the previous high, you can also see if it's a high probability that this is the area of the low. So if you have a retracement of 25%, the total retracement of the total price of 25%, and you have a 10-day time difference, so this would be pretty low here. So one could expect that this raises the probability that this could be a valid low, yeah. And this could be used to validate entries, for example. But further data engineering would be needed. Just a few quick words to the codes. I imported libraries as always, download historical data, and zigzag code, which has been shown previously in another video. These are the date time calculations and plotting. So the first thing we do is we make the date column to date time and we set it as index, and we calculate the time differences of the different dates. So we have the time delta, and we calculate the time delta, i.e. the time diff here, time diff column to days. Otherwise we are not able to calculate with it. And we calculate the close ratio column with the percentage change function and drop the NA values by subsetting the close ratio. This is important, otherwise it would not work, because you would have NA ratios because of the percentage change. And then there's an iteration over the data frame, and it's just to define if it's a high or low in the column pivot, which is added here. This pivot column is then used later for subsetting the data frame, so we can get two separate plots. We use shift to get the close of the next row into the current row. So this makes it possible to calculate the percentage difference between the two closes. So you can calculate the gain more. You can calculate the gain with this, yeah. And this is what we do here with next close divided by close for the lows, and for the highs it's close minus next close divided by next close. So this would be equivalent to a ROI, a return on a short. The percentage differences are then plotted. This is the chart here. Are then plotted with a SNS, with a Seaborn scatter plot, and yeah, U is pivot, style pivot. And the next two plots are just the x-axis is here as a log chart, and the size and the transparency, the alpha, is equivalent to the realized gain. So if you have a higher gain until the next top or next low, the size is bigger and the transparency is less. So you can see if it's a big, strong dot, you can see that the next close was a pretty good gain, yeah. And yeah, with the log chart, you can evaluate if the close ratio is far from the mean or not. Yeah. So I just wanted to show it to you. Maybe this could be of use for someone. All right. Okay. Goodbye.